Okay, we're having a little play with the ECUMaster PMU-16 today. I've got the software open here on my laptop. We're sitting in a 3rd gen RX-7 that we've been working on for a little while now. This car is using that PMU-16 power distribution module. We also have the ECUMaster switch panel here. We don't have it mounted yet, so excuse everything just kind of laying in here. We've been doing a lot of testing and just playing, really, seeing what features that we can employ on this unit, and it's a pretty neat little deal. And I'm going to go over one of the features that we're using right now, and kind of how it works and what you can do with this software and in this device. We've got I'll try to pull this menu down. The laptop's not working. There we go. Pull this down, kind of zoom in here. You can see we're running a power steering pump, fuel pump, radiator fan, 2-speed radiator fan, intercooler water pump for water to air intercooler. Our ECU and accessories are on a circuit. Injectors, we've got one open there, spare. We've got an oil cooler fan, got a circuit for our Plex display dash, fan high, our electric water pump, and then we're running 2 circuits for ignition coils. As you can see, this will display whether or not the functions are on. See, active, off, the percentage of the programmed load that you're using. So right now, the ECU is using 12% of whatever the fused value that we have programmed, and you can see right now it's running at about 0.6 amps. Excuse me. And that's real time. Over here it's pulled a maximum of 4.55 amps, and it's running at 15.9 volts. I have a battery charger hooked up to this thing right now, so the voltage is hovering right up around 16 volts. What I'm going to show you, I'm going to use our keypad to enable the intercooler water pump, and as you can see, I have run that already, and with a max of 43.75 amps, and that's in-rush current. It doesn't run at that high of a current draw, but when you first turn it on, you're going to get a big inrush. And you can see the same thing up here with the fuel pump. The fuel pump primed and it first came on, 72 amps of inrush. Down here, this radiator fan, we're using 2 25 amp circuits, so a 50 amp total continuous capacity. And on inrush, we got about 85, a little over 85 amps inrush. Okay, so the inrush is big on these motors, and we can monitor that. The running current isn't going to be anywhere near that, but it's just handy to know exactly what these things are doing. So what I'm going to do, I'm going to pull this chart back up, zoom out a little bit here, and this is real time, and it's going to graph. I'm going to manually, over here with our switch pad, I'm going to key this pump on and off, and you can see the state change on the keypad there. And I'm going to go back here, and you're going to see exactly what the real-time amperage does. You can see it spike up and then drop down and then go to 0 when I turn it off. And this chart, as you can see over here, is scaled to 50 amps. So again, I'll turn it on. We get our 40 some amps of inrush, and then the running current is very low. Don't have any water in it right now, so that's not indicative of what this thing will do when you load it down with water. But then we can go back here and we can look and see that that IC pump is running at a little less than 3 amps. So big inrush, but the amperage drops right down. This pump, when I do load the system up with water, is it's probably going to run about 12-15 amps. And so then I'll show you here how we can control this. I'll go ahead and shut that pump off. I'll double click on this and our setup page for this function pops up. You can see up here that we got the IC water pump. We're using a single 15 amp circuit, and I have it fused for 15 amps. So if it draws over 15 amps, it's going to shut down. We got 120 amp inrush set up. I'm going to go ahead and drop that down. We'll set that at about 60. Just show you how everything's programmable. And what it's going to do, go ahead and hit OK on that deal. Close that out. I'm going to bring it back up. Here we go. And the way this works, if you exceed your max running current, it will go, the circuit will go open, just like a fuse blowing. And then we have it set up to retry 3 times and retry every 1 second. So basically, if the fuse blows, it's going to replace the fuse, try the circuit again, and it's going to try it 3 times. And if after 3 times it still faults, then it's going to set a fault. And we actually have over here, you can see on our keypad, we have display buttons. These 3 here actually don't do anything except for display. And you have 3 colors that these buttons will display. You see the green and the red, and there's also an orange. These 2 buttons we have programmed through CAN to display ECU temperature faults. And basically what it's showing right now is we haven't had the car running. It shows that the engine is cold. So we have a cold limp set up in the ECU, so that with the cold motor, you can't just start it up and rev it to 10,000 RPM. There's a low rev limit, and that will remain until the engine's up to operating temperature. And these 2 lights are signifying that right now, engine coolant temp and engine oil temp. And once it's up to temp, once the engine's up to temp, these will turn green, and you'll be good to go. This button right here is a display for the PMU faults. So if we do have something go out of range, this will turn red, and it'll let you know you have a fault. And then this right down here is a reset button, master reset for the PMU. And if you press it, you see everything blink there when the power is cycled. That'll cycle power on the PMU. And when you do that, you reset all faults, and it's basically just a master reset. You can start all over, and it gives you 1 option as a driver in case you're having an electrical problem. You can reach down and reset it and give it a try. The other things we have here, we have another indicator lamp here that is for again ECU faults, and this is more of a if you have a check engine light situation where you've got low oil pressure or something like that, that's what that's going to be. These are manual override buttons, just like we had with our intercooler pump. Turn it on and off. And then this is a master power button. So when the master power button is off, the overrides are turned off. So that's how that works. And this piece here it communicates with the PMU, and if you look down here, here's a little PMU power distribution module sitting right there. It's about 4.5 by 5.5 inches. Small little unit. Down here, if you can see, can't really see, the lighting's bad. That's our Syvecs S8 ECU. And then come back up here, and you can see our Plex SDM 500 display dash. All of these units are connected via CAN bus. The ECU features programmable CAN bus input and output, and so we can program what the ECU is putting out, and then the ECUmaster stuff can also be programmed, and the Syvecs stuff can be programmed. So we took some time, set up a CAN bus protocol where all three units can talk to each other. And so we have one set of sensors that feeds the ECU, the power distribution module, and the dash. And then we can set up fail safes and turn functions on and off in the PMU with the CAN bus objects. And just to show you a little bit of how that works, we'll look at water temperature. Open that up and see how the protocol here, I can set all that up. And another really neat feature about the ECUmaster PMU is that you get live CAN bus data, and so you can see down here exactly what's coming through on this channel and what all the hex information is in real time, and then this will spit out your output value. And right now we're looking at water temp, and we get a value of 17 degrees Celsius. So it lets you know exactly what you're reading, and if you're reading a system, actually what we had to do with the Syvecs was we didn't know, we had the information, the bit and byte information, but we didn't know exactly the multiplier and the divisor up here, how that was going to work to spit out the proper actual temp number. So playing with this, we can look at it and then come up here and play with our multiplier and divisor until we get the proper output number. So if you don't know exactly what the CAN protocol is, you can use this information to decode it and make your power distribution module work with really any sort of CAN bus. And once you have that temperature information, then you can come back here and set up all your functions. And I'll show you an idea. Find the water pump. So we're running the water pump. It's an electric water pump. That is not what I wanted. It's the CAN bus info for that, for the water pump. Come down here to the water pump, and kind of like we went over with the intercooler pump, we got our water pump. It's a 25 amp circuit, 120 amp inrush, 20 amp running current. We have this one actually set up to retry forever. So if you exceed the max current and the circuit goes open, it's going to continue to retry it until you shut the motor down. That way, with the water pump, it's kind of important. We don't want that, if at all possible, we want it running. So that's why we have that set up that way. We're running the water pump in a PWM manner. The ECU is set up to output a duty signal based on coolant temp, and that will we've got that set up in our CAN bus. It gets the duty number out of the ECU and drives the pump that way. And then down here, this is how we turn it on and off. The ECU turns the circuit on, and then anytime the duty cycle is above 35%, the pump will run. 35 is kind of the limit, the lower limit of what that pump will run. So anything less than that is ignored. The pump stays off. Believe we have the the ECU programmed to start feeding a duty signal at about 120 degrees Fahrenheit. So as the engine starts warming up, the pump starts turning slowly, and then by I think it's about 175 degrees, we're full on running the pump wide open. So that's the primary control, the automated control through the ECU. And then down here we also have an override switch on our switch panel, and so that we can manually run the pump. If we stop the car between rounds, we can turn that manual override switch on. The pump will run as long as the water temp is above 77 degrees Celsius, and our master power switch is on. So that's the way that works. So you can park the car in the pits, turn the master power on, let the pump, and then we have the same thing with the fan. So you come in, the car's hot, you want to cool it off, you turn everything on, walk away from it, forget about it, and once the coolant temp is down to 77 Celsius, everything shuts off. If it sits there and heat soaks a little bit more, and the temperature rises up a little bit, it'll kick back on. You don't have to worry about, if you walk away from it, you don't have to worry about everything running continuously forever until the battery's dead. It will shut itself off. And that is it's kind of a basic overview of what you can do with this stuff. We got there's just a lot of capability, and between the Syvecs ECU being able to output duty signals and frequency signals, and basically anything you can dream up, you can do it. And the Syvecs can send those signals out over the CAN bus. The ECUMaster PMU is then capable of reading them, and you can just do all sorts of things. And basically, the sky's the limit. If you can dream it up, you can make it happen. One last thing I wanted to go over. I wanted to look at this Syvecs, or excuse me, the Plex dash, and it's probably going to give me a hard time here as far as contrast, trying to film it, but the Plex dash, you can see those buttons highlight. The Plex dash has a little toggle button here. You can see it's got a wheel that you can scroll by hand, and when you change it, you can scroll through different functions on this dash. And right now I'm turning functions on and off with this dash. And here we can make cal selections, and I'm going to cut this.